So the first thing I want to talk about today, and actually most of what we'll talk about today, is changing the language. So the first thing I want to talk about is adding and as a special form to our language, and then the problems that you guys will get to add or as a special form to our language. And then we'll talk about making a change where we're going to take lambda, which I always misspell, to make procedure, which I won't misspell. So we'll talk about how we could change the language so I wouldn't misspell lambda all the time. And then we'll talk about making a different type of call, basically a different type of compound expression in our language. That's what we're going to do today. So the first thing we're going to do is add and, which we'll call ADU and. So just to recall from scheme, if we have and expression 1, expression 2, up through expression n, and is a special form that's going to evaluate these expressions in order, one at a time, from left to right. And what does it do? It's going to evaluate all the and clauses. What if it finds a false one? Does it evaluate all the clauses? No. So we could have a case in which, expression n is some infinite loop, but because an earlier expression was false, we'll never hit that. So and is our special form that we're going to use, and we have to write this into our system. We have to write it as a special form. We don't want to just evaluate all of these expressions. We want to evaluate them in order. So we're going to add a line to MC eval, and I'm going to put it after the if question mark line. And that line I'm going to add is going to read and question mark expression eval and expression in the environment. You'll see that for all of the special forms that we're implementing, we're going to write a procedure. There's an eval if, there's eval, many of them, eval define, various things like that. Let's see, here we go. We have eval if, eval and, which is added, eval assignment, eval definition. So for the special forms, we have to have special procedures to actually control the evaluation order that we're going to be putting in. So we need to write and question mark. How would we define and question mark of an expression? Does anybody remember what form or what check we're going to use? We have something called tagged list, which takes an expression and then the tag. So we can use that here for our and. We can say tagged list expression, and we're going to use ADU colon and. Because remember, if we were evaluating ADU and ADU equals 1, 2, ADU greater than 2, 3. This is the same as a list structure like this. First is ADU and. This is the list ADU equal 1, 2, and this is the list of ADU greater than 2, 3. So what tagged list does is it checks to see if the car of the expression is EQ to the tag. In this case, our tag, what we're using as our operator, but we can think of as a tag for our expression, is ADU colon and. I'd also like to write a procedure called and clauses, which will take an expression and is going to return a list of the clauses that I need to evaluate in order to figure out what the value of my and is. So what would the and clauses be given the list structure that I just drew over there on the right? What would I write? How can I get these clauses? We're just going to do the cooter of the expression, which will return this, a list of our clauses, which is exactly what we want. We want a list of the clauses of our and. So now that we have a predicate to test if we've got it, and we've got a selector to pull out what we want to operate on, we now need to write a val and. So let's define a val and. Just going to take an expression and an environment. Remember, everything needs to take an environment. We need to evaluate within some environment. So let's talk a little bit about how we want to do this. I've got some lists of clauses. Okay, so here are my and clauses. What do I want to do? Let's just talk it through.
See if the first one's true, and walk down the list, and as soon as we hit false, we return false. To get to the end, we return true.
So that expression is true. I'll evaluate the rest of the stuff. Then I check if this is true. I'm going to evaluate the rest. Otherwise, I'm going to return false. Because as soon as I hit one that's false, I stop. There's no point to finishing off. Once I hit one that's false, there's no way the expression can be true. So let's just bail out. So what I'd like to do is I'm going to define an internal procedure called iter. Did you guys find where this is on the handout? This is on bottom 4, so you can follow along. It's there. So we're going to iter on our list of clauses. Okay. So I'm cootering down a list of clauses. If I'm cootering down a list, what should I do first? Check for null. So I'll write if null clauses, what should I return?
True.
Why? We made it all the way through the list. We didn't find anything false.
We didn't necessarily find anything true.
But we didn't necessarily find anything true. And actually, we'll talk about in a few minutes how to make this error correct. We're going to write it first, and we'll talk about how to error check for it. Okay, so if we don't have any clauses, we got through the list. Otherwise, what should I do if I've got some sort of clause list? Well, what do we say we're going to do over here?
Check to see if the first expression is true.
Check the first one. Okay, so how do I evaluate the first clause?
Pass it to the evaluator.
Pass it to the evaluator. So we say if MC eval, we're going to evaluate the first clause, car clauses. We need to pass MC eval one more thing, an environment. So we always need to evaluate with respect to some environment.
In your code here, you run if
You do it
false
differently, but this
question
will
mark.
work if you do it.
Did I write it backwards? This is actually the better way to write it. This is the way I wrote it in my notes. We can supersede the code there.
Which is better?
This is probably clearer because if this is true, then we're going to do something. Otherwise, we'll try first. It's exactly the same code. Would you prefer that I write it the way that's in the notes or this way?
This way's better.
No preference.
We just started talking about it this way, which is why I wrote it this way. I wrote it 2 different times.
Okay.
MC eval car clauses environment. If that is true, what do we want to do?
Either on the cutter of the clauses.
Do I want to return true? Let's not hear from Chris for a minute. All right, we want to do the next clause. We want to iterate, right? I'm going to iter on the cutter of the clauses. Otherwise, if this wasn't true, we want to return false. Okay. So now I need to make a call here. I can't just pass my expression, because remember my expression is a tagged list. It's got the ADU and at the beginning of it. But conveniently enough, we wrote a selector called and clauses. So we're going to iter on the and clauses of the expression. Note that iter, since it's scoped inside a val and, we don't need to pass it the environment. It's already got that scoped within it. So then when we call the MC eval with the environment is scoped from this procedure here, we don't need to pass it into iter. It's just part of it. Okay.
Thanks for running this. Yeah.
Okay. That was the sub-lecture. Sign language lecture, yes. So now we'll learn sign language. All right, so do I need to write anything more to implement and in my system? I've got to check for an MC eval, critical, because you wouldn't want to write all the code and then actually not check for it. I've got a way to figure out if it actually is a tag list starting with ADU and. I've got a way to pull my clauses, and I've got a way to evaluate it. Do I need anything else?
You need to check if the clauses are null at the start.
We should check if the clauses are null at the start. See, in your average class, I wouldn't figure that out, and I could lead you happily through a bunch of stuff and then come back to that. But sure, let's error check. So this is no error checking, which means that if we said ADU colon and, what would that be? Well, the clauses would be null, would go into iter, and would return true. So that's a little bit buggy, right? That's not a great concept.
That's our R4.
Is that R4? If that's R4, we don't have to change it. But I want to change it because I want to talk about how we could error check.
R4 doesn't need any.
R4 doesn't need any?
Paren is true.
Well,
Because
they were lazy. All right, that has no error checking. Let's actually write error checking. But it's okay. We don't have to be R4 compliant.
Wouldn't this be paren and empty list? Paren, is that what we're
Yeah, so right. So Todd had said that R4 says that that is true.
That's page 9.
I don't like that. I'm writing my own scheme. Therefore, we will do R4.2, and we will do what we want. So we're going to do some error checking. So this version is going to have error checking. So I raced off the line that called iter on the and clauses. So here's my error checking. What do I want to do?
We could either do a cond or
We can do a cons or an if, but somehow actually what I'd like to do first is we're going to need to use and clauses potentially twice. Because if it's not null, then we're going to pass it. So let's use a let. I'm going to let the clauses be and clauses of the expression.
What is and clauses return if there's nothing there? False or list or?
And well, it would return nil. Because remember, it's at least going to be a list. At the very least, it's ADU and the cutter of that is nil. So return the empty list. So we can call and clauses, which will be fine, and then check for the null here. So if null clauses, what do I want to return?
False or error?
No, return false or an error. What would make more sense?
Error.
Error would make more sense because we're being just as ambiguous if we say that this is false. And in fact, we're probably being even more ambiguous, right? That's kind of weird. It's one thing to say, okay, it's true. But if it's nothing, it makes it false. It'd be much better to signal an error. But if what? Huh?
That's just a semantic thing. But if none of the elements in an and statement
It's true.
exist, then none of them are true. So I thought, isn't the default for an and being false? I guess that's what we're deciding.
It's our language. We can do whatever we want. We can write it both ways. We could write error. We can write everything 50, 60 ways.
Now, would we want to actually do an error and put them into the debugger, or could we maybe just have it display, like list no clauses, and it doesn't put them into the debugger?
The default, pretty much in the system, is to pop them into the debugger, which pops them out of our system. It might be nicer to, obviously what would be really nice is if we wrote a debugger inside MC eval,
Right.
which of course you all can do for problem set 9, right?
Oh, yeah.
That's exercise 3. Yeah, right. So you start throwing stuff at me. Nah. But we could write a debugger, our own sort of thing, and our debugger up in this level could just be returning a list. But I'm actually going to pop them out into the external one, because that's where the debugger is. We don't have a debugger in our system. Otherwise, if we do have clauses, what do we do? I'm going to iterate on those clauses. Okay, so this is one choice to error out. Another choice would to go with Rob's suggestion that if there's nothing, nothing was true, therefore it must be false, which we would just write pound false there. Yes. So basically what you want me to do is, if I don't have clauses, I'll have the define internal to the if.
Yeah.
I don't think it looks as nice. I think it's kind of ugly, actually. I think it's... No, because you're still going to need to have a define and iter. You still need to define that.
You don't have to have the let. Can you just say
We don't have to have a let. We could make two...
if null and clauses, then error. Otherwise, do the rest of it and iterate.
Well, we'll still have to we'll still have to somehow get the and clauses again. Right? If we're going to need to iterate, we're somehow going to have to pull those out anyway. So we'll have to do it twice. So we can either use a let once or we can do it twice.
Where's this let going in? At the bottom?
So so this is the internal iter procedure that's defined, and then here's the let. So that error checking line is, I just put that there so we could comment that that was what was happening, but normally we wouldn't have that. It would just be bumped up with that code. Yeah. So it doesn't really matter in some sense whether we error out or we return false, or even if we return true, as long as we specify what our language is going to do, just like R4 does. So we could have ADU scheme R1, and we're going to do these things.
Would it be possible to give like a non-fatal error instead of saying no?
Right, so this is what was suggested before. So we could also do yet another choice would be list no values.
So that's going to return that up to whatever the evaluation is before and make it the show.
Right. This could make it have problems, right? Because if for some reason the and was a subclause, right? So we were saying if and blah, 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 and returned a list of no values, we get into some weirdness, but we have this whole thing in scheme where it's true because it's not false. So it's going to cause all sorts of weird things to happen. It's not going to be what we expect to be happening here. So this is probably not a good choice. Yeah. We can go with R4. We can return true. We can not error check and just have it the way we wrote it before. Yeah.
For when it gets sent to eval n, it sends the whole expression. But then, so won't the first thing you'd evaluate be the tag?
No, because right here we call and clauses here.
But that was your error check.
Well, before what we had is we had said iter and clauses. So that was the way it was before. We could have just as easily, right here, if we had said and clauses expression, then over there we would just know that we were getting the clauses.
I don't want to continue the tangent too far.
No, that's fine. Tangent good.
If you, maybe this was mentioned in another context, I'm not sure if you've done this, Michael, but if you were anding ands, for example, if you had nested ands,
Mm-hmm.
And you were mixing those nested ands with other things that were true, those nested ands, if they returned false, would make the whole expression false. I don't know why you would have empty ands inside another and, but it would change the behavior.
Sure. We are totally changing the behavior here, right? So we're not using R4 anymore. So if we decide it's going to be false, then it changes the behavior. In some sense, we could claim that it's fairly degenerate to call and with no clauses.
Oh, yeah.
You know, why bother? And if they're going to, the heck with them. The language will blow up.
Think of a situation, but then again, weird things happen.
Sure. I mean, it could be that some sort of dotted notation.
Why would you need nested ands at all? If any one of them is false, then they're all going to be false. So you can just string them out. Just for kicks.
John would like to say something.
Either of those two conditions can happen if you're automatically generating code. If your scheme procedure is actually generating code that is to be evaluated, it's very easy to create conditions where you either have nested ands or generate ands without any arguments.
But if you don't like degenerate ands, the heck with them.
That's a design choice.
Design choice. All you want to do, if you want to do that or not. So let's follow an evaluation through. I probably shouldn't erase that.
Defining the if, or did we define the if yesterday?
I think we pointed to it on the board, but we didn't actually do it. Or did you guys do it in recitation? No. We can look at if.
I'm just wondering, here we were able to make the and a special form because if it's already a special form.
Ah, no. Which if is that? That's a scheme if, right?
Right.
Which is a special form. So that's what you're saying. We can do this because we got the scheme if here.
Okay.
But we're not using the ADU if.
Okay.
So eval if looks like.
So we can't define a special form without basing it on a scheme special form. Is that correct? We can't. We don't have.
No,
the
no, we don't
power
have the power to do
define
that.
a special form on our own.
No.
We absolutely do.
I suppose we could do. With
Well, but
if,
we're
what else would be
we're
based
using the if underneath, though. I mean,
But we don't have to specify how it's. We'll do an example in recitation where we'll generate a new special form.
It's not based. That doesn't use another special form within it.
Because you can do any arbitrary process.
sure, we do arbitrary processing. But I mean, here we're using if underneath. So the question was, are we defining and using if? And we are. So sometimes this special form is relying on an underlying special form.
We shouldn't talk about it now. It's a subtle, I think it's a subtle.
Okay. Moving on. Let's evaluate something. Let's look at evaluating. Oh, goodness. Look, color. Can you guys read pink? Is this a good color? Huh? Yellow? Yes. Isn't yellow and white indistinguishable on the board? No? Okay. I'm going to do ADU and ADU equal 1, 3. ADU equal 1, 1. So if I type this in, some parens would be nice probably. Whack. So if we have the proper parentheses, this will result in a call to MC eval on this clause. in some environment. What environment are we in? The global environment, which is the global environment, which I would like to suggest that I may be able to abbreviate as TGE. Is this fine? Please? All right, so we're going to evaluate this in our metacircular evaluator. So if we look at our code for the metacircular evaluator, we're going to say, is this expression self-evaluating? Is it a number or a symbol? No. Is it a variable? No. Is it quoted? Does it have a quote tag on it? Does it have a define tag on it? Does it have a set bang tag? We did this in reverse order. Is it an if? No. Is it an and? Yay. So I'm going to call eval and on what? My expression.
Skipping one level of the eval apply list here, right? We dropped down through the list we applied to find ADU and.
Well, I sort of I waved my hand over. This is a call to MC eval, and I didn't write out all the cons, self-evaluating variable quoted.
Right, but it's none of these things, and we drop down to MC apply.
No,
And
it's not none of these things. It's and question mark.
don't we pass in the whole list first, and then we have to parse it individually?
We are passing in the whole list, and what and question mark asks if it's a tagged list starting with
That's right,
ADU
that's
and.
right, 'cause it's a special form.
Right.
Right, okay.
So there's our clause, our expression that we're passing, and we're going to pass the environment.
Quick question, how does it go from the very first step to the second step? I know we usually do Control-XE, but would that be...
That's when we start the evaluation. So basically, the driver loop is waiting to read in an expression. When the expression is read in, it calls it using MC eval. We can actually see the driver loop. It's on probably the last page of the handout or the second to last page. Right here. So if you look at the driver loop, third procedure down on page 10, it prompts for the input with the input prompt, and then it lets the input be the result of reading, and lets the output be the result of MC eval of the input in the global environment. So the driver loop has taken care of this for us. All right, so that's being done by the driver loop. That's how we jumped to that next step.
Can you somehow bind driver loop to Control-XE or something?
So basically, when the read is what, basically when we're doing the read, we're waiting for the Control-XE to be like the end character saying we're done typing in our stuff, read this current expression I just typed to you. That's what's happening there. Other questions? Excuse me. How does what? Input prompt. If input prompt is on the code that I just handed to Alex.
Which will not be available for a few seconds.
Which, if I could read it backwards, it says define. Input prompt is merely a string, if you notice, looking backwards through the paper.
And today's sponsor is Tide.
And here's Holly up close and personal. Yay. Everybody at home loves me. You like me, I know. Oh, you really. Anyways, input prompt is merely a string, so that we prompt for input, and prompt for input is just using a string there. So we could have put a different, we could have actually just put the string right there. But what this allows, with this little bit of an abstraction, we could change the input prompt if we wanted to, very easily without having to go into the driver loop to change anything. Check. Okay. Back to our evaluation. So here we are. We called eval and with our expression and our environment. So we go into eval and, which would be, oh, heck, I have the code on the board. There you go. Here's eval and. I'm going to let my clauses. It's much easier evaluating with the old one. I'm going to let my clauses be the result of calling and clauses on the expression. Would you guys mind if we sort of skipped over writing out all the let stuff and just say clauses will now be? Okay. Clauses will now be the list of those two elements. And it's not null, so we don't produce an error, and we call iter on those clauses. So we iter on the list ADU equal 1, 3, ADU equal 1, 1. Do I need to pass the environment? No, it's scoped. Okay, we're now in a frame when we are evaluating eval and in which the global environment, env is bound to the global environment. And John today in recitation is going to go through the chaining and creating of environments, show you guys how they're built up and how the lists are built up. So we'll talk about environments recitation today. So I'm going to iter on this. Here's my iter code. Takes the clauses. I check if null clauses. Well, is this null? No. So I need to go if MC eval car clauses, I'm going to do something. So let me write if MC eval car of my clauses. What's the car of my clauses? ADU equal 1, 3. And now, because I'm calling MC eval and I'm not going to be scoped within iter anymore, and because MC eval requires this, we pass the environment. So then I've got some more code here. We need to figure this out. Remember, because if is a special form and scheme, right? We're in the underlying scheme now. We're in white land, not yellow land. So if the special form and scheme says that we're going to check the predicate before we do anything with the consequent or the alternative. So let's evaluate MC eval on ADU equal 1, 3 in the global environment. So we go to MC eval. Well, is that self-evaluating? No. Is it a variable? No. Not quoted, not an assignment, blah, blah, blah. We fall all the way down to it being an application. Okay, it's not any of our special forms, and it's not a single element like a variable or a number or symbol. So we're going to call MC apply, thus spinning off our eval apply cycle, okay, on MC eval, the operator of the expression, which is the car, in the environment. So we're going to MC apply that to list of values, the operands, which is the cdr, or the list 1, 3, in the global environment. Any questions so far? Yeah.
So what is the expression after the operator?
It says list of values. And then we have to call the operands of the expression, which is the cdr.
I had a line before that.
This here?
No, the same line for you, but in the code it says MC apply, MC eval, for an operator expression.
Yep, so this is the MC apply,
Okay.
MC eval. The operator is the car of the expression.
And what's the expression?
The expression was this.
Oh, I'm sorry. Okay.
Because we called MC eval on this expression with the global environment, and then because it was an application, we fell through everything else, all the other checks, and we are MC applying, the result of the MC evaluating this operator in the global environment, and then evaluating the operands in the global environment.
Now, is our ADU equal? Is that a primitive procedure?
That will be a primitive procedure that we've defined. So if you look on page probably like 9, I would guess. Page 9, about halfway down, we define a bunch of primitive procedures. sorry. Okay, so define a bunch of primitive procedures on page 9, about halfway down. Okay, so there are the primitive procedures for all you at home. Okay, so MC apply, we need to figure out what the MC eval of ADU equal is, and we need to figure out the list of values 1, 3. So let's take care of MC apply on ADU equal. Is that self-evaluating? But it is a variable. So we're going to look up its value. When we look up its value, because it's a primitive and it's been bound ADU equal to be the primitive scheme, it's going to return the scheme equal, which I will put in a box to signify that we've actually evaluated that. So here's scheme equal. And now we need to do list of values 1, 3. List of values is at the bottom of page 1. I don't want to give up page 1. Did somebody get Alex a handout? And it says, if there are no operands, which is looking to see if the expressions are null, which is not true, we're going to, I'll take the evaluation out here so I need the more space. Cons, the MC eval of the first operand, which is the car, which is 1, in the global environment, 2, the list of values on the rest, which is the cdr, which is the list 3, in the global environment. So this will be cons MC eval 1 in the global environment, which is finally, thank goodness, self-evaluating, which means we just return itself. It's a number, we return the number, which means now we have 1, which has been evaluated in the scheme. Then we have to do the list of values of the list 3. Well, the list 3 is not null, so it's cons MC eval on the car 3 in the global environment. We cons that to a call to list of values. Oh, it loves me. With the result of the cdr, null, in the global environment. Okay, so this is still cons 1, and then we're going to cons MC eval 3 in the global environment, which is just 3.
What else self-evaluating besides numbers?
Symbols. Symbols. And then the list of values of null will return nil. This. When we build this back up, we get the list of 1 and 3. We've got an equal, and we're calling MC apply on that. So now we need to evaluate MC apply with equal on 1 and 3. On page 1 is MC apply. And the first thing we check to say, is it a primitive procedure? Thankfully, it is. So if it is a primitive procedure, we're going to apply the primitive procedure. And apply a primitive procedure is probably on some page I have now given away, which is unfortunate. I believe it probably was on page 9. Yes? And apply primitive procedure. Oh, here, let me just write that. We're going to apply primitive procedure. Of the procedure with the arguments. Why am I not passing any environment? It's all been evaluated. I didn't pass no environment here, and no environment here. Because when we get to apply, we've already evaluated everything. Remember the rule for evaluating an expression? Evaluate all the sub-expressions of our compound expression and then apply the first to the rest. We've done all the evaluations before we get to the apply, which is why apply does not need to take an environment, because everything's already been evaluated in its environment. Cool? Sort of? Maybe? Okay, so apply primitive procedure turns out to be apply an underlying scheme. So we're going to apply equal to the list 1, 3. By now, you guys are familiar with apply. Apply takes a procedure and a list of arguments, effectively breaking up that list of arguments for us. We're going to check to see if 1 and 3 are equal to one another, which is going to return.
True. False.
Like, whoa, alternate universe, man. Because we want this to be false, because if it were true, it would mean we would spiral off into evaluating the next one. But fortunately, it's not, which means this false is a result of when we evaluated this. So now we have if false. So we are not iterating. We bounce out and return false. And then the driver loop will take care of printing that for us. Speaking of driver loop, actually, yesterday when we were running, the question was, we were calling MC eval loop to start things running. MC eval loop creates the new global environment for us. If you guys bounce out because of some bug, you get into the debugger, you can resume by executing driver loop. So this starts with a new global environment, and this resumes with whatever is the global environment, whatever is in the global environment. So if you guys are halfway through your assignment and you've evaluated lots and lots of stuff inside the metacircular evaluator, you hit a bug because you put in your new OR and you made a mistake in one of the arguments, you can resume to get back where you were by doing driver loop. But you should use this to start up first, because you need to create the global environment. And you should also use that if for some reason you want a fresh start. Let's say you've been playing with it, you've done lots of stuff, and you just want to get rid of it all. Then you can reevaluate MC eval loop, and that'll clean out the global environment for you.
I assume that if we kill scheme entirely and then come back in.
If you kill scheme entirely, it's gone. Yeah. And hopefully you guys won't need to kill scheme entirely, but it could happen. And if you do have to kill scheme entirely, you lose it. The global environment's gone. Well, this variable for the global environment's gone. It'll create a new one when we restart. And that's actually mentioned in the problem set too. But that's how you do it. Yep.
Forgot how you got the equal from the ADU equal, because it doesn't equal any different things, right? And then where does it go to fetch the equal?
So this here, when I go into MC eval, variable question mark is going to be true.
Oh, because it's been predefined.
Right. And it was predefined as a primitive procedure when we created the global environment. When the global environment's created, anything that we have in our list of primitive procedures will be put into the global environment for us. So it's a variable. We look it up and we see that it was bound to be scheme's primitive equal.
Okay.
Yes?
I think I lost you at some point before when you went from the iter to the if statement, and then you went to MC eval,
Mm-hmm.
and we tripped on, you said it's application. The code includes a if question mark expression test.
Oh, okay. So if false. So we were looking at this version of eval and rather than the one that was on the paper. We wrote a different one on the board, so I was using the one on the board. Other questions?
On the back of this last page, there's two defines, unphraser list depth limit and unphraser list breadth limit.
Unparser.
Yeah, okay, whatever. What are those? Because they're not used anywhere. Are those affect something?
Those are going to be internals for scheme.
Okay.
and we are defining those. It actually is explained a little bit in the problem set. And it's basically going to prevent us from printing any circular list to too many levels. It's going to keep us going to infinite loops, because with our environments we're creating, we might set up some circular lists. It's going to prevent us from printing that out to too many levels. That's explained in the problem set. This is just about the couple of last lines on the last page of the handout. Unparser depth level, unparser blah, blah, blah level. This is just going to prevent us from printing out circular lists to too many levels and keeping us from blowing up. Because the environment will be a circular list. If you try to look at it, it might be a circular list. If we try to look at it, we don't get into problems. Okay. So let's look at some more changes. Do you guys have any more questions on and? When you're asked to write or, think about how we wrote and. Going to be kind of similar. Sort of similar there. Alrighty. What I want to do is make some more changes to the language. Because we're an ADU scheme, let's make some changes. Right now, we've pretty much been simulating scheme, except for this weirdness that we did with the empty and. We've been pretty much going straight along with writing a language that's exactly like scheme. But what if, because I continually spell lambda wrong on the board, for some reason skipping a letter, instead of saying lambda x times x, I want to say, what am I hearing? Bob. Okay, we could do Bob. It'd be shorter. Bob. I was going to say make procedure, but hey. That's so conventional, you know. We'll go with Bob. Okay. No, not Microsoft. Then it's Bob is going away. How about George? I like George better. Microsoft didn't co-opt George, did they?
They didn't get Bob either.
When I did my nerd kit way back when in 6004, which is the equivalent of the class that you guys will have on the machines, but you guys won't have the nerd kits. They used to have these suitcases you'd have to carry around to do all the wiring in it, and they called it the nerd kit. I named mine George. Anyways, too much information, I suppose. Okay. So, how do I make this change? Instead of lambda, I want to use George in my system. Where would I need to make changes? Changes to MC eval. I would claim that perhaps we don't even need to change that.
Define primitive procedures.
I hear define primitive procedures. We need to change, I could just change lambda question mark to check for a tagged list that started with George. Might be a little confusing because they're saying lambda question mark, George. But we could do that. So right now, lambda is defined as follows. Define lambda of an expression to be tagged list expression. In our sheet, it's ADU lambda. We can just go and write George or ADU George, whichever we would prefer.
But if it were George, then eventually we had a data structure with George as the student that would cause problems. We'll ultimately evaluate George even in an operator.
Well, actually, this is something else that comes out on the assignment, which actually talks about what happens if we're trying to redefine reserved words. And as it stands, we can. But you will make changes that will prevent that from happening. But this is ADU George. If we had a student, the student probably wouldn't be called ADU George. We could easily have a student, I suppose, called Lambda, too. But if we quoted it, then it would be okay anyway, so it wouldn't be evaluated. So we need to change that. I'd like to claim that there's one other thing that we need to change. Anybody have a thought? If we look at page something or other for the lambda stuff, 4, I'm hearing 4. There we go, top of page 4. We changed lambda expression to AU George. Do I need to change lambda parameters? Lambda body. Make lambda needs to change. So currently, make lambda is defined as follows. Define make lambda on the parameters in the body, cons, quote, ADU lambda to the parameter and to the cons of the parameter in the body. So here we would need to change ADU lambda to ADU George. Thus ends the change. That's it. 2 places. Now, we could argue that perhaps it would actually be nicer if we called this George question mark. Because if we're going to change it.
Isn't I thought the idea behind lambda question mark is that we're saying that's returning whatever defines the procedure, not the word lambda. So that if we're now saying George defines a procedure, lambda question mark will return. Lambda question mark is saying, is this expression a procedure?
Is this a lambda expression? George is now our lambda expression.
Right. So
all I did was basically do a string replace.
Right. But if you renamed it George, you're no longer saying.
Well, we're just saying that George is lambda now.
Yeah. It's a George procedure.
It's a George thing. George is now lambda.
Doesn't that sort of violate the logic of the MC eval, the top-level MC eval loop, being all the generic operators your language could have?
Well, this is an operator. This is a special form. In my language, George is now a special form.
I mean, I agree it works. I mean, but okay.
The question is, but why? Because we can.
Well, it seems like the point of the top-level MC eval loop is it's the most generic, so that any language, sort of in the theoretical world, could plug into the MC eval loop. However you define if question mark will go off and tell you if this is an if statement in our Swahili programming language.
Okay, so yes, MC eval actually doesn't need to change. We might change our tagging here. We actually have a syntax file, right? And that's what we're changing. There's a syntax. Syntax stuff starts on page 3 and goes on. That's all basically defines the syntax of our language.
Right.
And all we made changes to make lambda be George was make changes to the syntax file.
Right.
But what I was saying here is that in some sense, if we're now calling lambda George in our language, it's a George procedure. It's a George now. It's not a lambda. So maybe we should check George question mark instead of lambda question mark. It's not necessary. It's merely a string replace. All we would do is replace anywhere that lambda appeared in a question mark or lambda, whatever it is, lambda parameters, lambda body with George parameters, George body, George question mark, make George. Changes absolutely nothing, yeah.
So the question actually relates to, if I understand it, relates to syntax versus semantics, which is a well-studied issue. The syntax that we're changing is merely to replace lambda with George. And when we use lambda question mark or George question mark, we are merely checking the syntax. We're only looking for the tag of the expression. We don't know what the expression does when we're checking for the tag. It's what we do when we find that particular tag that defines the semantics. So we can put any tag, any arbitrary tag. It changes the syntax, but it doesn't change the meaning of that expression. And when we say lambda question mark in MC eval, when we're actually looking for that tag, that doesn't carry any meaning. What carries the meaning is what we do once we find the tag.
Okay.
So we're not actually saying, when we say lambda of an expression, we're not saying this is, in the syntax, we're not saying this is something that produces an expression. That's part of the semantics. That produces a procedure. That's part of the semantics.
Yes.
If you wanted to add a new thing like array that is not in scheme, you would put it in this MC evaluate dispatch section, wouldn't you? You'd have
Sure.
to check for array.
Right. So you want to add a new command array,
Yeah, so that would have to be in the dispatch. Right?
you'd have to put that in dispatch, right? Something, right? You'd need to deal with it.
This is not the primitives of scheme. The MC evaluator doesn't start with a special form.
It's basically any special forms.
In your new language. Yeah.
Right. So what we don't need to check for is if it's a primitive, because it'll just be bound in our global environment. We'll look it up and we'll apply it. And we don't need to put any checks for any procedures that we're writing. But any special forms that we're going to have, we do. And array, we could actually just bind to maybe be list or something, or maybe we would create some new data structure and do it that way, sure. But if we're going to do any sort of special evaluation, we should have a special check for it in MC eval. So, but I mean, we could write, rather than have it be within MC eval, you might want to write, we could write an array procedure on top of our evaluator, basically at the evaluator level when you get the MC eval prompt. Here we could define some procedure array that takes in some args, which would be nice if I had more space here. And then return the args.
If we wanted a new language to have a fundamental data structure, say,
This is not the way to do it if you want it to be in your language.
wanna put it
We want to put it down in the MC eval, yeah. But this is one way we could do it and run on top of it to see if it would actually work if you like what it's doing. You can run at the top level.
To be a special form, you put it in MC.
Yeah, yeah.
If you wanted it to act like a primitive procedure, you put it somewhere in the box.
Well, if you want to make it, actually, what we could do is, if all you want is array to be list, in your prim procs, you could make a primitive procedure called ADU array. Do I have my primitive procedure sheet? No, I think I lost that one. That's on page 9, right? I lost 9. Give me page 9. Thank you. So we define prim procs, primitive procedures, as a list of a bunch of lists. So we could make one list, ADU array, that goes to list. So we could define it as a primitive procedure. If all we wanted array to be was a list, then we could just bind it right there. And then we wouldn't actually need to change something. If we were going to do something special on it, special evaluations,
like a two-dimensional array.
then you might want to actually make it a special form, depending on how you were doing it. Other questions?
An ADU, if we were to define an ADU apply, would we just map it to MC apply? Or is there actually, like,
Yeah, if you were defining apply on top of MC eval, I would map it to the MC apply. You wouldn't want to map down into scheme, because then you're losing your level. We never want to jump 2 levels. So if you guys are writing stuff at the MC eval prompt, you do not want to try to access anything that's in scheme that hasn't been brought through the metacircular evaluator. So if there's a primitive that you want that I haven't given you, you need to add it to the list of these primitive procedures, and then you need to evaluate this, and you need to restart to get it into the global environment. Okay, so if you find that I just haven't given you a big enough list for what you guys want to be doing, because I've only given you plus, times, divide, subtract, a few list operators, and a couple of checks equals, greater than, less than. If you want more of the scheme primitives coming through, you would need to add them there.
So when you say we need to restart, we need to actually get out of MC eval and rerun the MC eval.
MC eval's loop, yep. Because if you don't, it won't restart the global environment. Because it's when we first create the global environment that these primitive procedures are read into the global environment for us. And if you don't restart that loop, if you don't reset the global environment, even though you've evaluated prim procs, nothing's gotten pulled into the global environment for us. Now, this is just a list that when we go to evaluate the global environment, actually, which is probably on page 9 or 10. Bottom of page 10, we say define the global environment to be setup environment. And then if we could find setup environment, which is probably on page 9. Here we go, page 9, halfway down, setup environment. We let the initial environment be the result of extending the environment with the primitive procedure names and the primitive procedure objects on the empty environment. So the first thing that we do when we're creating an initial environment is we put all the primitives in. And the environment, how we create environments, is going to be something that John's going to cover today in recitation. We're going to talk a lot about that. And then we put 2 more things in, true and false, and then we return that environment. So the global, when we first start up, is going to have all of our primitives and true and false. That's what the global environment is going to hold until we start doing bindings. So when we resume a global environment and we clean it up, that's all that will be there when we start again, when we do the MC eval loop. Yes? No, sorry. Yeah.
So to start everything up, to get into this ADU world, you do
No, we don't do setup environment. We're going to do, you're going to evaluate the application of MC-eval-loop. Okay, which will do it. Which will do it for us.
So once we're in this world, the reason why it's so important with the primitives is if we did square without ADU colon square, it wouldn't know what to do.
Actually, nothing in our language needs to be prefaced with ADU colon. We're doing ADU colon because it makes it easier to see which is where. But we don't actually have to have anything in our language that has ADU colon in front of it. What you'll notice in the book is they put, obviously they wouldn't put ADU colon, but they don't put anything in front of it. They're writing scheme and scheme. We're effectively writing scheme, but we're using these ADU colon tags to help us try to differentiate when we're in the MC evaluator level, when we're typing into the metacircular evaluator, and when we're using underlying scheme. That's the reason for putting the ADU colon tag on everything. It's just to try to help us see the difference. But
if you had square, would it go at variable? Would it be called at variable, or would it be called, where would that happen?
The answer is yes. Where could square go? Well, there's two things that we could do. One is that we could add square as a primitive procedure and try to get the underlying from scheme. So we could add list ADU square, square. And that would pull square from underlying scheme. Or we could just define it when we're at the MC eval prompt. And we can do an ADU define, ADU square. I'm going to tag everything, even the variable names. ADU times, ADU x, ADU x. So we could define square at our MC eval prompt. But when we quit out of our current state and we restart, it won't be there. If we did it as a primitive up here, every time we resumed, it would be in the global environment.
What I'm wondering is if you do neither. Or,
If you do neither, you don't have it.
or say square was a primitive. I don't know if square is a primitive. It's not, right? Or say we didn't define ADU plus, and then we used plus. Where would it, what would happen?
Something exists in scheme, but
Yeah, exactly.
Right. So if plus exists in scheme, but we haven't sucked it up,
Right.
not going to work. It's not going to find it. When it looks up the variable name, it's not going to find it.
That's right.
Because you can think of it as, basically, scheme has its big global environment. But within that global environment, we've created a variable called the global environment, which is going to have only in it what we've put in it. And if we don't put something in it, if we forgot to put plus in, then it's not going to work. We're not going to be able to get through. We cannot jump from the top level, the levels yesterday were 1, 2, and 3. We can't get from level 1, MC eval, to level 3, scheme. It needs to be mitigated through level 2 for us.
what causes that break? Because up to this point, when we were drawing environment diagrams and whatnot, every time we spawned a procedure or spawned an environment out of a procedure, it looped back to the environment that that procedure was defined in. So it seems like this, we would have a frame spawned by like the MC eval that would point back up to, that might produce a global environment, but that would also point back up to.
Because what's going to happen is, and you'll see this in recitation more, when we've got environments, if we have chains of environments, we'll have E2 that's changed to E1 that's changed to the global environment. The global environment here is not scheme's global environment, but the list of the global environment that we created and might have made changes to. But because what we're effectively doing is we're representing the environment as a list. And if we reach the end of that list, it's not like we can go from that list to bouncing out into scheme. So everything that we've defined is in a list representing our environment, and we can't get from our global environment in metacircular evaluator to schemes. Effectively, we're running in scheme, so obviously making changes in the global environment. But the environment, when we evaluate something, when we do an MC eval, the base, the last thing we look at is the global environment, which is a list. We hit the end of that list, and it's not there, it's unbound, even though it might have been defined in scheme's global environment.
Does the real global environment or the real environment model work just like ours in that what we've been drawing and thinking of as linked environments are actually just one big table where we add stuff on?
Lists.
Okay, lists.
Environment frames are lists, yeah.
We add
Yeah.
stuff on them. They're not really separate environments that are linked magically.
They're lists of
it's one big
lists.
environment
I mean,
that we add.
well, everywhere we are, we have an environment, and we have these pointers to follow up, and we're basically following these list pointer type of things from the box and pointer diagrams, the lists. One more example?
I have a question.
Okay. See, you guys have learned. Oh, no. Don't want to do it anymore. Yes. Must find it for the next 3 hours. I'll come back.
So we're defining. Oh, first of all, we can assign primitives that aren't scheme primitives, right? Like we could write our own. If say square didn't exist in scheme, or say we wanted to write cube, or I don't know, that might exist as a scheme primitive as well. But in any case, we can add something to the primitive list where we actually write the lambda there.
Yes.
And then that will be like an scheme
Right.
primitive. And then we won't have to rewrite it.
This is lambda, not George.
This is underlying scheme. This is lambda. Can't be George. We're in underlying scheme now. Yes.
Is that necessary?
Was what necessary?
Could you write define a primitive in terms of? Never mind.
Well,
Well,
here,
you define
the
it in
primitive procedures here, when we're defining the global environment, we're evaluating this stuff, we're in scheme. We're not running through MC eval at that point. So it's got to be with lambda.
Are we getting a problem set today?
Yes, we are.
Okay, and
Are we close to getting a problem set today?
I've been starting paying attention.
Okay. John will finish rereading the problem set, and it will go out within the next hour, hopefully.
okay, and in terms of commenting code and that sort of thing, I don't know how much that's been addressed in the ability for each assignment because it seems as if we are expected to reasonably comment our code. I've had a little bit of trouble commenting code within a function in terms of the interpreter just not being happy with that.
If your comments have parens in them, the interpreter can be unhappy with it for some reason. It shouldn't be, but it is.
I've just had it given trouble just putting semicolon in a comment and it just
Barking.
giving me errors, like trying to think of that as a variable.
There has been a little bit of weirdness.
Okay.
I've had Edwin goes from no parentheses to all lots.
Yeah,
Huh.
I've had some multi-line comments for whatever reason seem to be some issues, and there may be something else in there that it's finding.
Yeah. Yeah, I think actually, I've seen a problem. Actually, somebody had asked me a question once. Actually, I think it might have been Todd I went and worked with once. And if the comments fall within the code, sometimes they cause problems, and it's really funky. You can comment outside of the code before it or something, yeah.
So you don't really
Wait.
care about inline comments.
We haven't been really talking about inline comments that much. And so I mean, if you want to put, it would be nice before functions that you're returning in, especially if we say, extend the metacircular evaluator in some way and tell us what you did, describe it. It would be nice in your comments to say, I did this and this and this, it's going to work this way.
Right.
But if inline comments are giving you a problem, I wouldn't worry about them.
Okay.
Yes?
Back to that where you said that if we were going to add any additional primitive procedures, that we would have to get out of ADU scheme and then get back into it.
Mm-hmm.
I was just kind of glancing over here. Would it work to just run extend environment, primitive procedures names, primitive procedures object, and instead of the empty environment, do the global environment?
Yes, except then you're double defining some of your primitives. So your list is going to have 2 pluses in it, which will work fine,
Okay.
but it's weird. I would clean the global environment up. I would just clean it up, restart, redo it. Other question?
Clarify something about the variable lists in the environments. They're a list of pairs, right? Name,
No.
value. Okay, what are they?
It's going to be 2 lists. Did you guys do it as lists of pairs?
In the small evaluators, it's a list of pairs.
Not in this
It's a
evaluator.
small list in any case.
It's going to be a list. It's 2 lists, a list of 2 lists, where the first one has the variables in it and the second one has the bindings.
Oh, and they're just matched up
Yeah.
country-wise?
Yeah.
Okay, so when we extend it, there's no nesting going on, right? We're just
Right.
continuing it on.
You're just continuing that list. Now, if we're creating a new environment that's pointing to it, then we're starting to get some nesting.
Is that
Well, our new frame will be part of the list. Basically, our list will be added. There'll be a frame put at the beginning.
but
Rest
it's
station.
same level? Okay.
Huh? Yeah, it's all going to be the same level. It's going to be one level list where the start of it. So if we have this big list, like blah, blah, blah. At the end of the list is going to be the global environment stuff.
Yeah.
And then if for some reason we created some E1 stuff, that'll be up here.
This is actually two lists, like you're saying.
Let's let John draw it all out in recitation, so we're running out of time now. You'll just have to wait a mere hour and a half.
But and this helps explain why we can't get back to the global environment stuff.
Right. We're only in a list, right? We've got this list stuff, and if we don't find it in that list, we're not going to find it. We don't bounce out into Scheme. Other questions?